Engineering Open House. 18 teams competing in the Jerry Sanders Robot Design Competition. Who will come out victorious? With us we have Steve Granda. He will tell us about his experiences in his team, the Society of Hispanic Professional Engineers.
I've actually been doing FIRST robotics and stuff like that since high school, so when I saw the same kit we were using, I wasn't too fazed by it. But when I saw the actual competition, the Jerry Sanders competition, that was actually impressive. I mean, picking up frisbees and driving it around, we actually never competed at that high of a level of manipulation and stuff with robotic appendages. So basics for this competition for this year was we had to do tic-tac-toe. Earlier in the actual design phase, the competition was you had balloons basically with ball bearings inside of it. So your robot actually had to physically pick up these balloons and drop them into bins located all across the course. You basically have a tic-tac-toe. You get points by dropping balloons in the box, or you get more points by doing actual tic-tac-toe line. A robot is something without a soul. No, a robot is pretty much a remote control device or an autonomous device that is completely separate. It can be controlled by a human, or it can be controlled logically through some kind of program or algorithm to perform a specific task that otherwise a human couldn't do, or in this case a human could do, but we wanted to see if they could build it. We did have a robot from previous years. Previous EOH teams, we did have a robot. We did have already experienced people. So in a way, my freshman year, I did build the electronics box from scratch. Pretty much redesigned it and put new things inside of it. So we did have that pretty much set, but we actually just changed the actual design from 4-wheel to 3-wheel. Competition, definitely worth it. I mean, one of the biggest things that they have at Jerry Sanders, which I have not seen people take advantage of yet, are autonomous designs. So Intel and AMD actually offer a lot of money for people who are able to come up with algorithms for, let's say for example, in the competition we had this year, you drive around with a control, you pick up balloons and stuff like that. But if you're able to come up with a design of a robot that's actually able to do that on its own, drive up a ramp, pick up a balloon, and make a decision by itself, then you've already beat a lot of research and you're pretty much on your way to coming through a breakthrough. During the competition, I drove the robot over and decided to test it out. We didn't have any drivers at that point. And I was like, I probably have to drive this. So when I was doing practice on the actual course, I drove the robot up the ramp, and I realized that the weight distribution on the robot was completely wrong. So when I went up on the front end, the robot completely almost started flipping over, so I had to went up backwards. I was like, that's fine. So I just changed the mapping. I go up on the ramp backwards, then I go down the ramp again backwards. Robot completely flips over. We break our kill switch, we break our arm, we break the electronics box 25 minutes before competition. So we had to do a mad rush. Oh man, it's interesting because it's kind of a way for the senior engineers to pass on their knowledge to younger engineers. I made a lot of friends. I got to know people a lot more. I mean, when you're spending time, like at 5 in the morning hacking a robot with a whole bunch of people that you barely know, you kind of bond over time. And even with teams, like surprisingly, there's a lot of friendliness in the competition. If your robot breaks down, if you need a battery, another team's like, hey, you want a battery? You want to borrow our battery and use it for a competition? So the overall goal is for competition, and it's like really good sportsmanship. So it's actually really awesome. This year we placed 4th place, which was really awesome. In previous years, I mean, we got top 10. We were all happy, but this year, the fact that we got 4th place really said something. Our robot this year is the simplest design that we've ever had. In terms of coding, we started the coding completely from scratch the night before, and we were able to get it completely functional in about 6 hours with no code. And over and all, the code ended up to be a couple hundred lines, I think 800 lines of code in one night. Basically, I think people should get into robotics. You do not have to be an EC major. You don't have to be an engineer. You can start off with basic stamps, PS2 basic stamps. You can start off with PIC controllers. You can do the sumo bots, or you can do just little simple things. If you know how to apply positive and negative to a motor, that's your simple robot already. If you're an ECE major, you can get more, combinational logic, like the 110 cars and things like that. but anybody can really do robotics, and you should probably